Hello people, now we will do a very nice path for the AGV in this room. You can see this is a sample of a real plant. Here in front we will do a line from this part where there is the cable. We will go forward. Here we are lucky, we already have two magnets already set on the ground, so we will use them for our purpose. For example, they will be the initial point. Now I take the measure and they are 0.45 meters distance. So it's good enough for us. Then we will go forward up to here. And here on the left we will do a charge point. This is normally the standard CBAT point we will put in the red for the battery charge. And then the line will go forward, and this will be, for example, a production line that could be full of stations where we will need to load. And here on the right we will go make another line, and here there will be the second vertical line where there could be more stations to serve. Now we put the meter and we set 2 meters as the first magnet. In this way we will have a reference point. And then we go negative of 1 meter, so the point at -1 will be the parking point. I say -1 because in my opinion the 2 meters is the origin, so the first magnet of the two ones already in the ground will be the 0 point, and this is what I set. And the second one will be, of course, 0.45 meters. From now on, all the measures we will take along the line will be subtracted of 2, because 2 meters is the 0 point. Now we will go forward and we will try to check if this line is really going correctly inside the production area, which is the one with the stations. And here I can check the points and go forward, and now I can set a 6 meter point. This is the cross point that I will use in order to go left to the charging point. And then after this we will go forward, and here we have another cross point. Here this point is at 7.5 meters, and this is the cross to go right. And here we go inside the production line, where we imagine that there are many stations. For example, I put 1 station at every meter. Then finally the last one will be at 16. Now here on the paper we can make a little resume and we can draw the map we are doing right now. So we have 2 crosses at 6 and 7.5. From 11 to 16 we will have the loading station, the charging point on the left. And now we will put the laser. This is a standard laser to see some lines on the ground, to have a reference of straight lines. And mainly we will also check here the reference. One guy must stay in the other side, and so the first one can take the correct reference. And so now we can see the angle. We can have a perfectly 90 degrees angles, and so we can make the side line. Here we put again a reference to a good value, and now we can go on the left side and we can set the charging station. In my opinion, since this is just a sample, we are inventing values, and so I choose to put it at 4 meters on the left. This is the point where the AGV will stop with its center of body in order to be connected to the charging station. In order to reach the station in the correct way, we must always put a magnet 0.4 meters before. This is why we can achieve a very great result and very good precision with our inertial AGV system. Using a magnet just a few tenths of meters before, we can have less than 1 millimeters of precision. And now we can go forward, and we now can check the vertical line and take the measures for the other magnets. Now we put again the meters on the ground, and now we are going to take the measure and be sure of what we take. For example, since we will do the curve on the left, and the curve will be 1 meter long, I set the initial point of the curve 1 meter before the crossing point. And before another 0.5 meters, we would like to put a magnet. Or actually, since we do not just intend to have an X and Y reference, but also the correct reference of the angle and so the direction of the line, we put a double magnet. So each one will be 0.5 meters before the crossing point. Now we go forward and we have to put the magnets for the loading stations. And again, Since we wanted to reach the maximum precision and we wanted to achieve good repeatability of our system, we must put a magnet 0.4 meters before each station, and here I put a magnet point. Now let's go forward and let's do the same for all the stations. In your real plant, remember, you have to do this. Every station you need the AGV to stop with a very high precision. Remember, you have to put a magnet between 0.4 or also 0.5 meters before. Now we draw again and we would like to make another line. So we put the laser and we put it on the cross in order to see the reference. And now we will go right, starting from the 7.5 meters point. Now my colleague is standing the meter and we will choose, according to what we see, a crossing point. In this case, we will see, for example, a 3 meters distance is suitable enough to make the cross point. This cross point will be used for the AGV to turn from the horizontal line going right to the other vertical line going in the second area of the loading stations. Now we will move the laser, and here we have to set it in the perfect perpendicular position, otherwise the error would increase so much. My colleague will put the foot, and here we can check and move the laser to make it coherent and touching the other point on the first line. Now that the 2 points are set, we know that the line is perfect, because between 2 points there is only one line. And now I can put again the meter to put a reference, and we can see. Now my colleague is going forward and checking the line. We see that the line is really going inside this area. And here inside we would like to put some stations. Now, since we already made this kind of job, we will just put a couple of stations. So one station after 4 meters, and this could be another loading station, for example. Imagine your plant is doing some kind of load and load stuff. And as we know, before any kind of station we would like a magnet that has to be put 0.4 meters before. And so the 3.6 meters is the magnet point. Finally, just to finish this line, I will check with my hand that the meter is always on the laser line, and here we will put an unload station in 7 meters. And so, of course, a 6.6 meter point will be the magnet. Now we will just make a drawing and we set the curves we want to do. And after the curves we will just set on this paper the kind of the map we want to do. This is a good thing to do, because you will keep a note of what you are doing, and then you have to draw it on the RAT, which is the Robox AGV tool. The map you will draw in this way must be exactly the same, and this will be the one we will use for our Robox AGV system. Another important thing is that we are setting the double magnet before the curve. As I said before, this is important because this will make the AGV to have a reference also for the angle and not just the X and Y. This will correct any angular error. Now let's begin to put the real magnets on the plant. The first two are already put. So now we take some magnets. Here on my hand you can see a group of surface magnets. They are 1 mm thick and they have 10 mm of diameter. But their magnetic flux is so weak, so we take two ones together. In this way we have a couple and their flux is enough to be detected by our magnetic antenna. Now we will put these magnets on each of the M points we have defined before, because each of the M is a magnetic point. So while the AGV will come over this point, it will detect the magnet and make the correct correction in X and Y. Now you can see we are using some tape to stick them on the ground. This is very convenient for you while you have to make your lines, while you want just to test some magnets, some reference points. And you can put them, take them out, just a little modification on the RAT and they are okay. Otherwise, you can later put some other magnets when you have already tested your system and you think the magnets are suitable to be used forever in your plant. You can use some definitive magnets. In this picture you can see some cylindrical magnets. They are more they are longer, and so you must drill the ground to put them down. In this way, their magnetic flux they give is more sharp, they have more precision, and they will help the antenna to detect in a better and more precise way the position of the AGV. Otherwise, you can see in this image an armored magnet. This is stronger, so this is more suitable to give also to the magnet more resistance to any kind of heat. But finally, if you just think that you do not want to drill the ground, and if, for example, the customer is not allowing you because of some maybe cables underground, or just because they do not want to drill the floor, you can just keep using these kinds of surface magnets. These ones are so slim, so you can just put a couple of them, as I said before, in order to have enough magnetic flux, and then you can just keep them stick on the ground with some glue, silicone or rubber, just to make them stable forever and to avoid that they get lost or destroyed by some other human or machine activity on the plant. Okay, now we begin with RAT, so that's a Robox AGV tool. We give a map name, so this is let's say plant green. Okay, that's inertial guided AGV, yeah, but I'd like to use the extended format just to have more possibility. Now it's asking me about the transversal navigation, and that's enabled. All user point, no need, absolute positioning, nothing, okay, good. Inside vehicle, okay, here is just some other information. And now let's begin. Let's make a vertical line. And now I just make a random line, and I must set the points. So, okay, first point is from 0 and 0. So let's begin from the origin, and then let's make 0. And vertically we have 16 meters, but then we have one more for park. Okay, let's say 20 meters, it will be enough. Now let's also move the origin at 2 meters. So you can see now the arrow has come here, and here we will put the first magnet and the second. So this magnet will be in 0.45 as we recorded, and this one instead will be in 0. These two magnets, as I said just now, must be selected, and they can be used as a double magnet for the initial point. The initial point, as we know, is the triangle, so I put it here, I put it here, then I say that's 0.45, that's there is no need of any code, starting index number 1. Okay, good. Now, as we said before, there will be a parking point, so we do a user point, which will be our station, and that's set in -1. And since we always want our lines to allow our AGVs to go even a little less, I'm also doing this generic point just as a lower limit. And finally, let's go and check the other magnets we have to do. On my paper, I wrote 1 in 4, 1 in 4.5. Then there will be 10.5, sorry, 10.6. Let's make more ones. Okay, if I remember correctly, they should be like this. Now I will say the last one was 15.6. Then I remember 11. 11.6, then this one is 10.6. Very well. And now here these two are in 4.5, and the other one was in number 4. Okay, now these two again are double magnets because on these two we would like the AGV to correct both the position and the orientation. So since these two magnets are the ones before the curve, which will be set at 6 meters, so it's more important to have also a reference of orientation. Normally the single magnet, like all of these ones, are used just to give a correction before the stations. So for example, let's make the station. This is 16. Okay, so that's 11.0, and let's give a code. This will be, for example, station 101, and that's load 1. Here we have load 2, and that's 102, and this is 12.0. And here again, let's call it load 6, 106, and that's 16 and 0. All right. Now, as I said before, here we have this line, and let's make a cross. As always, we press first on the horizontal, then on the vertical line in order to have the quadrants as mathematical standard. So 1, 2, 3, and 4 in this way. And in number 3, we are going to make a curve, which is 1 meter, and okay, that's everything, but I'm quite sure the position of this line is, it's a random line, so we would like to make it, as I said before, this should be a 6 meter, so let's take the distance. This is 5.5, and no, we would like more, and so this must be 8. And this is again 8, and the first point, okay, we remember we have to go left of 4 meters, so let's say I'm going of minus 4.5, and positive is just not important, 0.1 could be enough. Anyway, we just care about this curve, so we don't need anything else. Now, the line position is here, so we put 1 point and 1 magnet. Now, the position of this line, we can take a look, we can see the distance is 4 and something. Okay, 0.8 maybe. Let's take a look. And that's 3 meters dot 7, so no, I need to make it 0.3 less. And here again, this point is, this should be 0.9. So, as we said, as we wrote in our paper, 3.6 meters and 4 meters. Okay. And this is a charge point, so let's take it out again. I'm sorry. Let's cut and let's put a battery charger here, and let's put its position in 0.5. All right. Very well. Now we know that this line was put in at this position, which is 8 meters, and so I will do another one in, we need 1.5 meters more, so it will be 9.5, and the line will go right. If I just move the mouse like this, the line can have any orientation, but if I keep pressing Shift button, it can be only vertical or horizontal. So I'll move it like this, And then here I'll write the positions, and so I will say, okay, that's already 9.5, and that's again 9.5. And let's say that the begin position could be minus 0.1, just to have some more. And here this is 3 meters, so we just do a 3.1, and the origin could be a 0.1 in order to have easy calculation, because you see the arrow is here, so it's in the same point of the cross. Now let's do the cross from here to here, and let's say that quadrant number 4 is going to have a curve, and up to now we just keep it like this. While here we are having another line, from here, I'm pressing the wrong button, and here again let's make it high, and let's say that's 9.4 is the initial point. Alright, so we keep having some little more space before the cross, and let's say we have 3 and 3, and then let's say this point can go up. Now we will check the distance. Actually this line was up to 7 meters, so we can make it starting from 9, let's say almost 10 meters could be enough, so almost 19. Okay, that's not important anyway. Now we are just using some points to lock the line and only use the part we need. Number 2, always 1 meter, and so on. And now let's draw the other stations. Okay, so we take a station and we put it here. Now first, I have to put also in this point in 0.1, you see I put the origin, so it will be quite easy to put the other points. This will be directly 3.6, and the station will be in 4 meters. This is another station, and let's give 201, and this is load, okay, load B1, let's just give a name. Here below did I write the code? No, 250. Remember that the code is compulsory for the stations, so for user points. And finally we have one more magnet, and one more station. So that's in 7 meters, and this again is name is unload, and that's for example point, let's call it 250, no, let's say 300. Okay, let's make it easy. And this one is 6.6. As always, we put magnets 40 centimeters before the station to have a good precision while arriving there. And then to finish the lines, we just put some generic points. Normally we could set their orientation, their direction as only backwards, but now it's just a test, so we do not care too much about this. And I still miss one station here, that's 13. And of course, before this, there will be another magnet in 12.6. Now, as we made before, you see that we put a magnet 40 centimeters before every station in order to reach that station with the maximum precision of Robox system, which is even less than 1 millimeter. And that's almost our target. Now I think the map is finished and we can save it. And sorry, file, save project as, and okay, I already select a map folder inside the AGV manager project, and let's call it, okay, let's give a real name. This is the green plant.xml. And now let's compile. Oh, it says there is a problem. User point code is not defined. Yeah, sorry. My fault. This was load 2 102. That's load 3 103. Let's save and let's compile. Map file name, let's call Robox map, just because this should be the name already used by our AGV system. Okay, and in fact we can read here below Robox map.map has been generated. And yeah, I still miss a vehicle, so I put it here. The color, okay, let's make it green, a little darker. All right, that's the color we want. And now just some settings. Okay, that's absolutely pointless, but I like to have this. All right, save again, generate again, and we are happy. Now let's open the AGV manager and set what we need. I need to open the configurator, and after pressing enter I will quickly press alt and I say Robox AGV manager. Okay, that's it. Okay, let's just give a name green plant, and let's say the map is the Robox map we made today. All right. Other things about the AGV. No, the IP address, yeah, that should be correct. PLC, no one, database, no IO, save and quit. Very well, now let's open the AGV manager in order to see the plant. Now I don't like these settings. I'd like to see the map vertically. So let's close, let's open this. Let's go here on map and let's say line 1 angle will be 90 degrees. Save and quit. Let's begin again. And now that's correct. Now let's make the vehicle in initial point search 100 and go automatic. Now I'd like to see my AGV. Oh, sorry, I made it in the wrong position. It is not backward, but forward. Go automatic. Very nice. Now I can take the AGV and, for example, move it. Now I must become installer. And now let's, for example, say I'd like to go to charging point. And here we can see the AGV is moving. We can make the emulation speed a little higher. Okay. So here is our AGV. Let's move it back. Yeah, we may add some points here below just to break the movement. And now, for example, we can go forward. We can go to these kind of stations. Nice. Now let's see if I want to go here. Yeah, you see, because I didn't put any points in here, he must go back and then go forward again. And now let's look at this. The AGV is making the standard curve, but since today we are using a omnidirectional AGV, here we can make a constant attitude curve, and that will become much better movement. So let's close this. Let's make little modifications to the map. Let's, for example, put a generic point. So if here the magnet is in 4, let's put a generic point in 3.5. Never put a point in the middle of a double magnet because this would make problems in the correction of AGV. Normally here the AGV should never be stopped, so let's put points either before or after. But since after these two magnets there is the curve, yeah, another point could be set here, but coming back from the curve is better to touch the double magnet to make a correction. This will give more safety to the stability of your system, and then just go forward. And here let's take a look at this line. I can say side navigation, this could be enabled. And for example, I can take out the longitudinal navigation. And together with this, I can go here in quadrant number 4 and enable the constant attitude. Now I make bigger, I will make this part bigger to let you read better. Constant attitude curve, and I will say, yeah, enable permitted always. All right, and here again, in number 2, let's open and let's say constant attitude. This is what we call CAT. This is something you may have already learned in previous videos of Robox SPA, and this is the way we like to move. So the AGV will make a curve, not rotating its body, but keeping the body in the same attitude and only moving the wheels. Now you will see in simulations. But to make it even easier for the system to understand this, let's also put a user point. Okay, it could be good to stay here. And let's say that allowed orientation should be, now let's say, transversal. All right, now let's save. Let's also add some other generic points. Generic points. These kind of points will help us to break the movements while the AGV is going around. So they are just some points where the AGV can stop, make inversion, and give the way to other AGVs if present. Now that's just a sample, but these kind of points may be very useful. So it's good to put these points somewhere to let the AGVs to break the movement in more pieces, and they help for the calculation. So now like this, also one in this line. Very nice. 2 and 49 means 2.5. Let's save and let's generate the map. Oh, one other thing I like to do is to put here the time and date, 2023, December 15, and now it's 14 and 44. So while we are going to reload the map on our real AGVs, we will also see the updated time, and this is a very big hint to understand if the map is updated or not. Now the AGV is in this position, let's move it. For example, let's make the same movement as before, and you can see here. Now take a look. Okay, now it was too fast, but you can see, first of all, thanks to this point, the AGV has no more need to go back to this point. And now I will make slower the simulation time. And while I'm asking the AGV to go again here, you see the shape of its movement. And so in this line, it will not make just a standard curve, but will make a cat. So moving side and then getting back to longitudinal direction. That's quite what we would like to do. Now let's close this, let's close, and let's do not forget to open again the AGV configurator and take out the emulation. So let's kill it. Another password will be requested to disable the emulation. Let's save and quit. And now let's connect to the real AGV. Here now I open the RDE. Okay, let me check the lost reg, and here inside we can modify the name of the configuration file we have to load. And now let's check inside the configuration file, the parameter file I want to use. Let me check. Yes, it's this one. This is the correct file because we can have more ones in the same project and then load the one we want. Okay, here we have the name of the map. So here I call it Robox map, which is the one we are going to use. Let's check here the name I saved in the RAT. You can see here below. And now let's check it. And okay, now we can easily load these files inside the RP2 of the AGV, and of course also the lost reg, because inside there is the name of the parameter file. Very well, this is done. Now let's reboot finally. Now we connect with the Wi-Fi to the AGV. And now the first thing we have to do is to check the map, and here we send to vehicle. In case you already have a previous map, you can see it in the AGV and you can check the date and time. Now you can see this very beautiful double view of the AGV manager on my PC, and on the right side it is me playing with the AGV. Now I have started the 0 cycle, so you can see the steering wheels are rotating on themselves, and each one is rotating back in order to touch the maximum stroke. So while the mechanical part, while we see that the torque is higher, we understand it's 180 degrees, and we go back to 0. Now the AGV is ready to be put on the map. Now here, I'm sorry you can't see it so very well, but here you can see the digital dispan. Here I go in initial point and I have compensated the antenna. This is something automatically happening while you start doing your initial point. And now I press the dead man in order to make the AGV move on magnet 1, magnet 2, and now the AGV is calculating the distance, understanding it is in the 0.45 meters initial point, and now you can see it on the AGV manager. Now it is ready to move, and here we finally can see the beginning of our AGV plant in this place, in this storage room. Now, for example, I drag the AGV on the AGV manager to the first station that we called 11. And now we go forward and you can see the real AGV and the one shown in the AGV manager that are of course moving in the same way. Now while the picture of the stop is on the AGV, it has finished the mission, so I can send it to the last line, to the last station on the line. I hope you are looking at the stability of the AGV and you see how well it goes inside the line. That's because we made a good job. We put the line in the center of the real corridor and we put the magnets. You can see all the magnets on the ground sticked thanks to some tape. Now the AGV is getting back to go from the left to the right line, and it has to go over a double magnet. Now it is what it has done. Now again you see 1 and 2. So the two ones below are the double magnets that are helping the AGV to correct the angular error. And here we do the CAT, the constant attitude curve. This is some of the most special tasks and special motions that Robox AGV can do. This is something that we have set before in the RAT, and now we can play the AGV and set it to the charging point. Now the AGV is going back. I hope you see again how stable it is. My hand is not so much while holding the phone. Now the AGV is doing again a CAT, so moving on the side, then another CAT, so a constant attitude curve, in order to go to the line number 1. Touch the double magnet, you can see the two ones again in front of the wheels of the AGV, and after a little correction the AGV is moving again, and now it's turning on the line of the battery charger. Now there is the magnet before it, and then here there is the station that we simulated to be the battery charger. This is a good sample of an AGV plant, and as you can see we can start from 0 and we can do everything you need to make your AGV to move on your customer side plant in just a few moves. And now we are moving the AGV by dragging on the AGV manager, but if you want you can write your X script on the AGV manager in order to control it according to the logic you need. So thanks for watching this video and keep developing your AGV system with Robox Motion.